In this video, we are going to see a common problem in SQL Server called the cardinality estimation error. It's not really an error, but the way the optimizer behaves. But yeah, if there is a problem, there is a solution. So let's go and understand what cardinality estimation error really means. For the purpose of demo, we are using AdventureWorks 2016. There is a table here called sales order header, which has a lot of sales data. Let's go and execute. And you will see that this table has 31,000 rows approximately. So 31,465 precisely. So there are 31,465 sales orders. And look at the attributes. Apart from sales order ID, we also have an attribute which is the salesperson ID. That's there here. Let me move it a little this side. Salesperson ID. Now we want to write a query and find out how many orders have been procured by each salesperson. So here is a very simple select statement where we group on salesperson ID and then we use the aggregate function count to get the count of orders. And we'll see that 285, salesperson ID 285 has 16 orders, 287 has 39, so on and so forth. Now we have a query. We want to find out we want to extract all the orders by salesperson ID 285. So we write a query, select start from sales.sales order header, where salesperson ID is equal to, instead of hard coding 285, we use a local variable. And this local variable is declared as integer here, and we assign the value 285 to the local variable. And now we are using the variable assignment. So let's go and execute this query. So the only catch here, the tricky part is instead of hard coding 285, we are using the local variable assignment. As expected, you get 16 records if you look at the status bar there. And I want to turn on the actual execution plan and run this again. And let's jump over to the execution plan. When you look into the execution plan, let's go and see this. Apart from, okay, let's ignore the missing index hint, etc. You see a scan plan. And if you take the cursor over the arrow here between the select and the filter operator, you can see actual number of rows is 16. But here goes the tricky part. The estimated number of rows is 1748. What's happening behind the scene is the optimizer, while compiling the plan and optimizing it, makes an estimate that about 1700 rows are going to be returned, but in actual only 16 rows are returned. This is what we call as the cardinality estimation, and this is where the error is, the cardinality estimation error, 16 versus 1700. Now, this query ran in just like a second or so, but in real world, when queries run slow, then we go and look into the execution plan. So of course, we are making some assumptions here, assuming let's say the query is running slow, and you jump over to the execution plan and you're trying to figure out why is the query running slow and where are the tuning and optimization opportunities. And in doing so, you figure out, okay, somewhere cardinality estimation is going wrong. Now, what I want to do is let's take a copy of this query here, and let's first really see that would optimizer give a different plan if we had hard coded the value. So instead of @SPID, instead of using the local variable, I will put down 285. I'm hard coding it. And now I'm going to run both of these queries, the select statements together. So when you run them together, of course, both of them are going to produce 16 rows each, and you get the 32 rows there. Let's jump over to the execution plan. And in the execution plan, here comes the difference. You can clearly see that with the local variable assignment, you're getting a scan plan. But when the optimizer really knows the value of the variable, or in other words, when the variable is not there and it knows what it is optimizing for, it produces a seek plan with key lookup. And the catch here is, look at the plan cost. So we have 92%, which is the scan plan, versus 8%. Huge difference. And what about the cardinality estimation in the second case? Let's take the cursor over here and look at actual number of rows versus estimated number of rows. 16 versus 16. Perfectly fine. Now let's go back to the query and take a step back. and what makes me think is, where is this estimation of 1700 coming from? So if I go back to this query, this one, and we saw, okay, 285 was 16 rows. Let's take another salesperson ID. Let's take 275, and this guy has 450 orders. So what if I put 275 here? Is that going to change the estimation? Let's go and execute this once more. Execute, jump over to the execution plan, and let's take the cursor over filter here and see that now actual number of rows is 450. This is what you expected, but the estimation still remains 1748. What is going on? Before I tell you the answer here, let's go and change it to anything else. Let's just put any number, a salesperson ID that does not even exist. Let's go and execute this. You know that when you put something like that, you're going to get 0 records because that salesperson ID is not there. But jump over to the execution plan, take the cursor over the arrow here, and you can see estimation still is 1748. This means that you put any ID here, it does not matter. What's happening behind the scenes and how the engine works is, the optimizer does not know the value that is assigned to this local variable until runtime. In other words, during the compilation and the optimization phase, the optimizer has no idea what is the value of @SPID. It only gets the value during runtime. So the plan uses a default guesswork. And that is the reason why you put any salesperson ID here, you assign any value to this local variable, it will always use that hard-coded default guesstimate. And that gives you the output 1748.06. Okay, so that's the engine and how it works. Hopefully there was something new to learn here, but now you want the answer, how to fix cardinality estimation issues, how to fix cardinality estimation errors. How do you make sure that the optimizer gives you this plan, the seek and the key lookup plan instead of the scan plan? Well, the answer to that, I have recorded another video showing you the demonstration how you can fix this, and this video is available in the premium section of this YouTube channel or the premium membership on SQLmaestros.com. Either way, whether you take up the membership in YouTube or SQLmaestros.com, you will get access to our premium content. Now, here is the fun part. Each week, we are recording a SQL Maestros video tutorial on Thursday, and we are putting it up on the free section of our YouTube channel and the free membership on SQLmaestros.com. So that is one video each week, and that is totally available to you for free. But now we have also started producing one premium video each week, which is only available in the premium section of the YouTube channel and the premium section on SQLmaestros.com. So you could take up the premium subscription. It is very normally priced either on YouTube or on SQLmaestros.com. The choice is yours. If you take up the premium subscription on SQLmaestros.com, you also get some extra goodies, and probably the pricing is slightly lower as well. So continue to leverage all the content that we have to give you. I mean, if you decide not to go with the premium content, no worries at all. You will continue to get a lot of free tutorials and demos from us. But yes, we would love it if you take up premium subscription as well, either on YouTube or on SQLmaestros.com. Happy SQL!